G'day and welcome. I want to tell you a little bit about a cool robot I built as part of my 4 robots in 4 weeks challenge. It is a Scorpion shape-changing robot designed for nuclear inspections. So the robot we're looking at is the Toshiba Irid Scorpion. It's designed for going into the Fukushima nuclear plant and is there to this day. And its main mission was to go and find the corium, which is the part of the reactor when it melts down and it melts through the reactor housing and then it mixes with the other materials. It's this sort of really hazardous, terrible material called corium. And it was very important at the time to understand what was the condition, where was it going, because the authorities needed to figure out how they were going to deal with this incident. And so this particular robot was designed with a movable arm so that it could go and change its shape and move into various, get through holes and things as they were trying to put it to get as close to the reactor as they could. So if we look at this robot, we can see that it's actually fairly complicated. So it's got 2 cameras. It's also got a radiation detector. It's got 3 joints in this sort of tail or the Scorpion arm. It's got 2 differential drive tracks for moving, and also a camera joint on the bottom camera. I'm not going to model the bottom camera joint just because there's already a lot here, but this is the sort of robot that we're trying to model. And so here you can see the FreeCAD model of that robot with all the joints all assembled in their correct place. This is pretty cool. I couldn't really build the tracks. There was a few systems in Gazebo for building tracks, but instead we're just going to have these 3 wheels there. So in order to simulate this robot in its environment, we need to think about what the mission that this particular robot was designed to do. And so you can see here, TEPCO very kindly published some mission summaries of what happened, how they got it in there, and what they saw. You can see the pictures of what they saw down the bottom. And so this means that we're going to need to simulate something called a pedestal, a reactor, core rods. Also, it goes down a CRD, so a control rod drive rail. And it gets in there by going through a pipe that was drilled into the side of the enclosure. So we have to build these models in FreeCAD. So we just it was actually pretty fun to make a silly model of a sort of a broken reactor with a big hole in it for us to get in. A CRD rail in the mission. This robot found that the rail was broken and so it couldn't proceed. So we've built a CRD rail that's broken and an entry pipe. And so this is what the simulation looks like. The entry pipe is in green, the robot is red, and you can see the large reactor housing with the sort of green, corium sort of stuff around it. And so finally, here's the simulation that we did. So in the first part of the simulation, you can see the robot has to change its shape, has to push its tail back so that it can fit into the entry pipe. And then in this second section, we're moving out of the entry pipe and onto the CRD rail so we can traverse down it. And then in this final part of the simulation, we get to about as far as the robot can go without falling off the CRD rail, and it's able to look around with its camera and create a sort of a map of this environment. So thanks everybody, that's a quick summary of the robot that we built. Thanks to all the companies involved in making this robot, and I'm glad that it was able to achieve its mission of going and seeing the corium many years ago as they were trying to figure out how to deal with the Fukushima incident. So if you're interested in building your own robots or trying to understand how to simulate robots, you can come and take my challenge. I run a whole bunch of capability upskilling challenges over at roborenegades.com.